Now we're looking for the equation of a tangent line, so our goal is the equation of a line, y equals mx plus b. I'm going to take you through the steps for this example, but then watch until the end because I'm going to show you some of the more challenging examples that you'll see on your homework and on your exams. Now to find this equation, we need a point, and our point is going to come from that x is equal to -1, and we're also going to need to find the slope, and the slope is our derivative y prime. Let's go ahead and start by finding the point. To find the point, I need an x and a y value. I know that x is equal to -1, and to find the y value, I'm going to use our function. So y is equal to -1 cubed plus 2 times -1 squared. That's going to give me y is equal to -1 plus +2, and we end up with 1. So that point that we're looking for, x is -1 and y is +1. So we've got our point, but we also need to find the slope. And the slope is just that derivative. So I'm going to take our function and find the derivative. Now our function was y is equal to x cubed plus 2x squared. Let's find the derivative. So y prime is equal to power 3. So I'm going to bring that 3 out in front and subtract 1 from the power. So I get a squared there, plus 2 times the derivative of x squared. So let's do that power rule again. I'm going to bring the 2 out in front, so times 2x, and I subtract 1 from the power, so it's x to the first. Let's just call it x. And we've got that y prime is equal to 3x squared plus 4x. Now this is my formula for y prime. It's the slope anywhere along the curve, but I really need to know that slope at my x value -1. So we can say at -1, so at x is equal to -1, y prime is 3 times -1 squared plus 4 times -1. Okay, so what do we get? We get 3 minus 4, and we end up with a slope of -1. So m for the equation is equal to -1, and we had that point, which we lost up above there, as -1, 1. Now you could definitely use y equals mx plus b to find the equation, or you can use point slope. I'm going to use the point slope formula. I think it's a little simpler for these examples, but both will totally give you the same answer. Okay, here's point slope. Y minus y1 is equal to m x minus x1. X1 and Y1 are our coordinates. So that's going to be X1 and Y1. And we've got M here as -1. Lots of ones floating around here. So we're going to go Y minus Y1, which is 1, is equal to -1, x minus our x1, which is -1, so x minus -1. We've got y minus 1 is equal to -1 x, that's going to be a +1, and now we're just doing the math. Let's distribute the negative on the right-hand side, -x minus 1, add the 1 to both sides, and we get y is equal to -x. Now, the great thing about the equations of tangent lines is you can check every single one. I'm going to check this first one in Desmos, and with the next example, we're going to check that one with the TI calculator. So I've got my equation graphed here, the function, and I'm looking for the tangent line right here at -1. I can just type in my tangent line equation, and that was y equals -x, and I can see, that looks amazing, that I've got this line tangent to the point at -1. Here comes the next example. Let's find another tangent line, this time for f of x equals x e to the x at x equals 0. And of course, our goal is that y equals mx plus b. Well, we know that we need those two things. We need a point, so we need an x comma y, and we need our slope, and the slope is the derivative. That was an f of x notation, so I'll call that f prime of x. We're going to start with that point. I know that x is equal to 0. I need to figure out what y is, and I'm going to do that by plugging 0 into my function. So that's going to be f of 0, which is 0 times e to the 0, and that's going to be a 0. So my point is at 0, 0. So I've got the point, 0, 0. Now I'm ready to find that slope. And to find that slope, we're going to do the derivative of our function. And we're going to need a product rule because that function is x times e to the x. So I'm going to take the derivative of x first, which is 1, times the second function, e to the x, and I'm going to add that to the first factor, which is x, times the derivative of e to the x. But the derivative of e to the x is my favorite one because it is just e to the x. So now I've got this formula for the slope anywhere along our curve. So here it is. So this is my m, but I need to figure out what my slope is at my point, and that is when x is equal to 0. So I really need m as the derivative at 0, and I can go ahead and plug 0 in where I see an x. So it's going to be e to the 0 plus 0 times e to the 0. Well, that guy just goes away, and I'm left with e to the 0, and that's going to be 1. So I've got my slope, which is e to the 0, that's going to be 1, and I also have that point, so the point of tangency is at 0, 0. Now I'm ready to use the point slope formula to plug those in. Try pausing the video, plug that in, and see if you get the same equation as me. If you're going to follow along with me, here is point slope. Y minus y1 is equal to m x minus x1. x1 is 0 and y1 is 0. M is 1. Plugging those in, oops, I forgot a parenthesis. Plugging those in, again, really nice numbers. You can tell I made these up. So y minus y1 is 0, is equal to m, which is 1. X minus x1, and x1 from that point is also 0. So we end up with y on one side is equal to 1 times x on the other, and we get y is equal to x. Let's check and make sure that we've got this one correct. I already put in the original function ready to graph, but I also want the equation of that tangent line, which is just y equals x. Let's go ahead and hit the graph key, and you can see here is the original function. You could even zoom in if you wanted to, and there is that tangent line. It looks great. Here's another really great one, the tangent line of the sine of 2x at x equals pi halves. So I'm going to throw a little trig in here to challenge us. But again, our goal is y equals mx plus b. So we know right off the bat that we need a point, an x comma y, and a slope m, which is going to be our derivative. And we're going to start with that point. We know that x is pi halves. We need to figure out what y is, and we're going to do that using our function. Y is equal to the sine of 2 times my x value, which is pi halves. Cancel those pi halves, and I get the sine of pi. Well, the sine of pi, if I think about my unit circle, pi is over here. I'm starting here. I'm going to rotate this way to get to where pi is in radians, and my y value is my sine value. My y value here is 0, so I land at the point 1, 0. Super quick little trig lesson, but the sine of pi is 0, and you can check that with your calculator too. Okay, so 0. So I've got that point, pi halves. I'll put it in green so we don't lose track of it, comma, 0. The second thing that we need is the slope, and the slope is that derivative. So we know that the slope m is equal to y prime, and that's going to be the derivative of the sine of 2x. As I take the derivative, I'm going to use a chain rule. So I'm going to start with the derivative of sine, then I keep the 2x, and then I'm going to chain on or multiply it by the derivative of the 2x. Okay, here we go. The derivative of sine is cosine, so I've taken that derivative, but I leave the inside unchanged. And now I'm going to multiply that by the derivative of the inside, and the derivative of 2x is 2. We can more simply call that y prime our slope anywhere along the curve, 2 out in front, cosine of 2x. But what we really want is the slope at x equals pi halves. So we're going to do m at our point is going to be 2 times cosine 2 times pi halves. This is going to be 2 times the cosine of, cancel those 2's, of pi. Now the cosine of pi is -1, so I can go ahead and replace cosine here with a -1, and I end up with 2 times -1, so the slope of my tangent line is -2. So that, along with our point, pi halves comma 0, is going to give us everything that we need to put this into slope-intercept form. If you're feeling good about your skills, challenge yourself to pause the video. Otherwise, follow along with me. Slope-intercept form. Y minus y1 is equal to mx minus x1. I need even more room. Make sure I've got my slope and point there. So y minus y1, that's that guy, so that's a 0, is equal to m. M is -2. X minus x1, which is pi halves. Now the left-hand side is just y, so I can write that as a y. Let's distribute that -2 into our parentheses on the right. So I get -2 times x, and then I get -2 times negative pi halves. Those 2's cancel, and y is equal to -2x. That's going to be a plus pi. Now we do not need to just hope for the best here. Let's check this answer in Desmos. I've got the original function graphed. I just want to put in the equation of the tangent line, so grabbing a new cell, I've got y is equal to -2x plus pi. So plus for pi, I just type pi. And I can see, let me move it over just a little bit, that I've got the tangent line correct. This next one is for you to challenge your skills as you're looking for the tangent line of this cubic function where x is equal to +2. Pause the video and then come back and see how you did. Let's find that point first. So I've got x comma y. X is equal to 2, so I'm going to plug 2 into my original function. Y is 5 times 2 cubed plus 3 times 2 squared plus 2. See if I can do this math right. 2 cubed is 8 times 5, that would be a 40. 2 squared is 4 times 3 is 12 plus 2. So this is a 54. So that point of tangent C is 2 comma 54. Next, we need our slope, and m is the derivative of our function. So here comes our derivative. So y prime is going to be 5 times the derivative of x cubed. Take your 3 down in front, subtract 1 from the power, plus 3 times the derivative of x squared, which is 2x, and the derivative of 2 is equal to 0. Let's simplify what we've got. I've got 3 times 5, which is 15, x squared, plus 6 times x. This is y prime, but I need that slope at the point of tangent C where x is equal to 2. So when x is equal to 2, y prime is equal to 15 times 2 squared plus 6 times 2. I should have made my numbers easier. That's going to be 15 times 4, 60. That's not too bad. Plus 6 times 2, I can totally do that, which is 12. And y prime is equal to 72. So I've got our slope and I've got our point, 2 comma 54. Let's plug these in x1, y1, m. Okay, so y minus y1, which is 54, is equal to m, 72, x minus x1, which is 2. Y minus 54 is equal to, distribute that 72, 72x minus 72 times 2, that's 144, 144. I need to add 54 to both sides, plus 54, and y is equal to 72x. 144 plus 54 is going to be negative 90. Now again, I encourage you to plug this into either Desmos or your calculator. Let me know how you're doing down in the comments below. Watch this one next.